So right here we have 8.3 WSP. This is our homework. I believe we're going to take 2 days to do this. So you could do maybe odd ones today, even ones tomorrow, or I don't know. You could do it all tonight. But let's start by explaining the odd ones right here. Again, we're going to be distributing one item at a time. Simply distributive property. Q times Q. Q squared. Q times 5. Positive 5Q. How about 6 times Q? Positive 6Q. And how about 6 times 5? Plus 30. So we have 4 terms. Notice that I didn't stack them up on top of each other because it's only 4 terms. And out of those 4 terms, the middle ones are the only ones that could be combined. The plus 5Q plus 6Q, you get positive 11Q. And the rest stays the same. The Q squared comes down. The plus 30 comes down. Super easy. Right? You guys should be loving chapter 8 so far. It's been cake. Let's move on. Number 3. Again, we're distributing one item at a time. I like drawing arrows because it'll really help you from making mistakes. And I like using different colored pens. I go n times n. That's simply n squared. N times negative 6. That's simply negative 6n. Then I change colored pens. This negative 4, and notice that I circle it because I'm including that minus sign. A lot of people make the mistake of thinking that it's just a 4. It's actually a minus 4, which makes it a negative 4 when you multiply. Negative 4 times n, that's simply negative 4n. Negative 4 times negative 6, that's positive 24. 4 terms. Out of those 4, you could combine the 2 middle ones. So if you owe 6 and you owe 4, you're going to owe 10. You're going to owe 10 of those n's. The n squared simply comes down. The plus 24 simply comes down. And we're done. Let's try number 5, which is not on that side. It's over here on this side. Number 5. Let's distribute. It gets a little bit more fun because we're finally getting some coefficients in front of our variables. Right? Let's go 4b times b. What do I get? 4b squared. That's right. And then I go 4b times negative 4. Negative 16b. Excellent. And now let's go positive 6 times b. Positive 6b. Positive 6 times negative 4. Negative 24. Out of those 1, 2, 3, 4 terms, I could combine the 2 middle ones. Now let's do that. Let's combine the negative 16b with the positive 6b. What do I get? Negative 10b. And of course, the 4b squared comes down. The minus 24 at the end comes down. And that's it. That's your answer. Easy peasy, lemon squeezy. Simple as popping a pimple in a dimple. It's gross. And it's not that easy, actually. That was bad. Number 7. Let's distribute one at a time. I want to take the 6a. What is 6a times 7a? 42a squared. Again, coefficient 6 times coefficient 7. When you distribute, 6 times 7 is 42. And then a times a, that's a squared. Let's move on to distributing the 6a over here to the negative 4. So 6a times negative 4? Negative 24 with an a. And how about negative 3 times 7a? Negative 21a. And how about negative 3 times negative 4? Positive 12. And again, I'm not stacking them up because I only have 4 terms. And out of those 4 terms, the 2 middle ones we could combine. So let's combine those guys. We have a negative 24a and a negative 21a. What do I get? Negative 45a. You owe $24. You owe $21. You're going to owe $45. And of course, we're going to bring down the 42a squared, bring down the plus 12. And that is your answer right there. Moving on, number 9. Distributing 3a times 2a. What's up? 6a squared. 3a times negative b. What the heck? The variables are not the same. But it's okay, yeah. How about this? Listen to this, guys. Let's go again through the process. there's an invisible coefficient, -1 right there in front of the b. So when I go coefficient 3 times coefficient -1, that will be the coefficient -3. And when I go a times b, it's simply ab. Because ab is, what does that mean? It means a times b, right? So you just write it. Let's distribute the other term now. The -b times 2a, what do I get? -2 AB. And some people say BA, but you know, it's better to put your variables in alphabetical order, AB. And then -b times -1b, it's technically a -1b times a -1b. What is, a negative times a negative is a positive b squared. You could put 1b squared, but you don't need to. I would just leave it b squared. Again, 4 terms. Out of those 4 terms, we could combine the 2 middle ones. So if I owe 3 of those guys, and what do I mean by those guys? I'm talking about the AB term. And I owe 2 of those same AB terms. I'm going to have negative what? 5 of those AB terms. And of course, the first term, 6a squared, comes down. And the last term, plus b squared, comes down. And that is the correct answer for number 9. Let's move on to number 11. Finally, get to some fun stuff. I was getting kind of bored there. We have a binomial times a trinomial. Now it might be worth stacking, right? Because on a binomial times a binomial, you only get 4 terms most of the time. And you're able to combine the 2 middle terms. Right here, you'll see it's a little different. So let's distribute. M times m squared is? M to the third, m cubed. How about m times 4m? 4m squared. And how about m times -8? -8m. Easy peasy. Now let's distribute the plus 5. 5 times m squared. 5m squared. Now notice, I could put plus 5m squared. If you want, you could do that. But instead of writing it over there, I'm going to match it up and put it right below my other m squared term. Okay, so I'm going to erase this one because it's a little more organized to start lining them up already. Now let's continue distributing. 5 times 4m, what do I get? Positive 20m, and I might as well write it below the other m term because those are the terms I'm going to have to combine anyway. And then 5 times -8? -40. And now that they're lined up, it's as easy as this, combining the red line with the blue line. So m to the third, there's nothing to combine it with. It comes straight down. M to the third is the first part of your answer. 4 plus 5 is 9, and we are talking about the m squares. -8 plus 20, that's plus 12, and we are talking about m's. And the -40 also just comes down. I think it's very convenient to stack them up like this, right on top of the terms that you're going to be combining anyway. It really does make it more organized and easier. Let's move on to number 13. Number 13, distributing 2h times 2h squared. What's 2 times 2? 2 times 2 is 4. But how about h times h squared? H cubed. Right? You do the coefficients first. 2 times 2 is 4. H times h squared is h to the third. Now let's continue distributing. 2h times 3h, that is positive 6h what? What is h times h? H squared. Okay, and last but not least, let's go 2h times 4. What do I get? Plus 8h. Okie doke. Now let's move on to the 3. Distributing positive 3. 3 times 2h squared. 6h squared. Where am I going to write it? Below the 6h squared. So put positive 6h squared right below it. And how about 3 times 3h? Multiplying. 9h. And where are we going to put the 9h? Right below the 8h. And 3 times 4, 12. And there's nowhere else, there's no other nice number without a variable. So that's the constant at the very end. Let's combine these lines. 4h to the third comes down. That's the first part of your answer. Plus 12h squared plus 17h plus 12 at the very end. That is a cubic polynomial. That's your final answer on number 13. So I definitely recommend stacking. It helps. Let's move on to number 15 here. On number 15, we're going to be distributing, okay, again, we have a binomial times a trinomial. We could even be more specific, say we have a linear binomial times a quadratic trinomial. It's really just all distribution, and we're going to be distributing one term at a time. In this case, I want to distribute the 3q first. So I go 3q times 9q squared. Coefficient 3 times coefficient 9, what do I get? 27. 27 what? Q to the third, because q times q squared, right? Q times q squared is q to the third. Okay, now let's continue distributing. 3q times negative 12q. Well, 3 times negative 12, negative 36. And how about q times q? Q squared. And last but not least, let's take this 3q and multiply it by positive 4. 3 times 4 is 12. And what about that q? Just slap it on there, 12q. We've distributed the 3q. Now let's move on to distributing the 2. I don't have to worry about this anymore. Now, I like to circle whatever I'm distributing, especially if it has a term in front of it. Like right here, it's positive 3. I don't have to worry about it. I don't circle it. Right here, the plus sometimes might be a minus. I like circling. I'm going to distribute 2q times 9q, 2 times 9q squared. What do I get? 18q squared, right? So where am I going to write that? I could technically go 18q squared, but it's better to do it under where? The 36q squared, right? So let's put the positive 18q squared right under it. That way we know we're going to combine those q squared terms. Now let's continue to distribute 2 times negative 12q. What do we get? Negative 24q, and of course we're going to put that negative 24q right below the other q term. And last but not least, 2 times 4 is 8, and there's nothing to combine the 8 with. There's no other number without a variable. So now I'm just ready to combine the like terms, and I'm doing this kind of like in a linear combinations method. The 27q to the third comes down, nothing to combine it with. The minus 36 plus 18 of those q squares, it's like owing $36 and only having 18. You're going to still owe 18 of those q squares. And then right here, you have 12, you owe 24. What's up there? What do you get? You end up owing 12 of those q's. And then the plus 8 simply comes down. And there's your final answer, 27q to the third minus 18q squared. Minus 12q plus 8. Classified, just for funsies. What is that? Cubic polynomial. Excellent. So on this video right here, we're doing the odd ones. 17, look at that. That's stinking nuts. That one's going to be ugly, but beautiful at the same time. Let's distribute one term at a time. I'm going to distribute the 3n squared. 3n squared times 2n. What do I get? 6n to the fourth. How about 3n squared times n? Positive 3n to the third. How about 3n squared times 9? Positive 27n to the second. Okay, we've distributed the 3n squared. We don't even need to look at it anymore. Let's move on to our next term, the middle term. It's going to be a little bit ugly, like I said. The plus 2n, when I go plus 2n times 2n squared, what do I get? Positive 4n cubed. Now, where am I going to write that at? Under the other n cubed term. So positive 4n cubed is going to go right under the 3n cubed. When I go 2n times n, what do I get? 2n squared, and I want to write that 2n squared right underneath the other n squared term. And then 2n times 9, that's 18n, and there is no other n term, so I just write it 18n. But this was not just a binomial, it's a trinomial, so we still need to distribute that minus 1. So let's take that minus 1 and go negative 1 times 2n, that's negative 2n, or negative 1 times 2n squared is negative 2n squared, and you're going to write that answer underneath the n squared terms. So negative 2n squared. And then negative 1 times n, that's going to be a negative n, and you write that underneath the other n term. And then negative 1 times 9, that's going to be a negative 9, write that at the very end. Now, if you don't stack them like this, it's going to be ridiculously long, right? But if you stack them, it's not more organized, easier to deal with. It's pretty easy to simply drop down the 6th end of the 4th, and that's the first part of your answer. The next part, 3 plus 4, that's going to be positive 7 of those end of the thirds. And then right here, we know that the positive 2 of these guys and negative 2, those cancel out, so it's just going to be a 27 left over. So it's going to be positive 27 n squared. And then the next term is going to be 18 take away 1, which is 17. And of course, we're talking about n's, and the minus 9 simply comes down. So this really ugly looking problem becomes not that ugly when you stack them. If you would have written it all out, man, it would take seriously like the whole page or half the page. But stacking them, it's a little bit more organized and easier to deal with. So that's your answer, a quartic polynomial. You don't have to label them, I'm just keeping the vocab in it. 19, one term at a time. Negative 12x squared times negative 12. Why did I say 12? What? Brain fart. 2x squared times 2x squared. 4x to the 4th. Once again, how does this work? Coefficient 2 times coefficient 2. 2 times 2 is 4. How about x squared times x squared? X squared times x squared is x to the 4th. And let's move on to the next term. 2x squared times negative 4x. Negative 8x to the 3rd. Because x squared times x, it's x to the 3rd. And then we move on to 2x squared times 3. What's that? 6x to the 2nd. That's right. Let's move on to the middle term. And the middle term, I'm going to do in blue. Negative 2x times 2x squared. What do I get? Negative 4x to the 3rd. I want to write that underneath the other x to the 3rd. And then negative 2x times negative 4x, that's positive 8x squared. And negative 2x times 3, that's going to be a negative 6x. The last term we're distributing is a minus 3. Minus 3 times 2x squared, that's negative 6x squared. And you're going to write that underneath the other x squared terms. And then when we go negative 3 times negative 4x, well, that's going to be a positive 12x. And you're going to write that positive 12x underneath the other x terms. And last but not least, negative 3 times positive 3, that's negative 9 at the very end. Now we're ready to combine these 3 lines. The first part of your answer is going to simply be 4x to the 4th. When I combine negative 8 with negative 4, that gives me a negative 12 of those x cubes. When I combine 6 with 8, I'll get 14. Take away 6, it gives me back to 8. So I'm going to get a positive 8x squared. And of course, you could have said, oh, 6 and negative 6. 6 and negative 6 cancel out. 8x squared is the only answer. And then when you combine the negative 6x with the positive 12x, you get positive 6x. Bring down the minus 9, and you are done. Quartic polynomial again. And I guess we'll stop on number 19. Or should we do 21? No. 21 looks fun. Let's do it. Since we're doing the odd ones here. Just for funsies. We want to find the area, right? That's what it says. Represent the area. What's the area of a triangle? Anybody remember?
100.
What are you saying? Broccoli. Chocolate. What? 1/2 base times height. 1/2 base times height. Okay? But the area of a square is base times height. Right? And any square, half of a square is really a rectangle. I mean, half of a square is really a triangle. So the area is 1/2 base times height. Anyway, what is our base?
4x plus 2.
And what's our height?
2x minus 2.
Okay, so I am going to do this part of the base times height. And then once I have my answer, I'm going to multiply it by half, which means divide it all by 2. Okay? So, or you could even write it out if you want. You could say 1/2 times the base, which is 4x plus 2, times the height, which is 2x minus 2. Bless you. So let's distribute 4x times 2x, that's 8x squared. 4x times negative 2, that's negative 8x. And then you move on to the other term. The other term is 2 times 2x, that's positive 4x. I'm not going to stack them because it's only going to be 4 terms. 2 times negative 2 is negative 4. And of course, these middle terms, the negative 8x and the positive 4x, that gives you a negative 4x. So far we have 8x squared minus 4x minus 4, and we still need to multiply that by 1/2. Right? The 1/2 out here still comes down. So we're going to just distribute the 1/2, which means divide every term by 2. So my final answer is going to be 1/2 of 8. That's simply going to be 4 of those x squares. 1/2 of negative 4, it's simply going to be negative 2 of those x's. And 1/2 of negative 4, it's simply going to be a minus 2. There's your final answer for number 21. We didn't have to do that one, but we did. I do believe there's one mistake on one of the answers on the back. Try to find it and let me know, yeah?